So, hello YouTube. Today I have just seen the video of the derivation of tetration of x that was on blackpenredpen's channel, and he asked at the very end if there was a way to find a generalized formula for the nth tetration of x. So as he said, we derived the derivative of d by dx, the tetration or the third tetration of x. Yes, now and at the end he got some result, but we want to find out what is the derivation of the nth tetration of x. Yeah, so I immediately decided to try and give this a shot, and here is a solution that I found. So I'm going to start off basically the same way. I'm going to write this as d by dx of x to the n minus 1 power of n minus 1's tetration of x. So basically the same thing. Yeah, and then like he did, I'm going to just do this e raised to ln x to the power x tetration n minus 1. Then going further is equal to e raised to ln x times x tetration n minus 1 into d by dx of x tetration n minus 1 times ln x. Okay, so this part on the outside is simply x tetration n. This is going to be multiplied by ln x, is 1 by x times x tetration n minus 1 plus ln x into d by dx of x tetration n minus 1. Okay, all right, so I'm going to multiply this inside and get the term inside. Okay, so this is going to be x tetration n times x tetration n minus 1 upon x plus x tetration n ln x times d by dx of x tetration n minus 1. Okay, now x tetration n gives us this result. Okay, so x tetration n minus 1, let's see if we can get a similar form to this. This will simply be equal to, let's bring these terms down as they are, x tetration n times x tetration n minus 1 upon x plus ln x multiplied by x tetration n, and in brackets here we should get a similar, an analogous term to this. So this will be x tetration n minus 1 times x tetration n minus 2 upon x plus ln x times x tetration n minus 1. Okay, can you see? Yeah, x tetration n minus 1 times d by dx of x tetration n minus 2. Okay, all right, so collecting these terms, we have x tetration n plus x tetration n minus 1 upon x plus ln x times x tetration n times x tetration n minus 1 times x tetration n minus 2 upon x plus ln square, ln x times ln x, ln square x times x tetration n times x tetration n minus 1 multiplied by d by dx of x tetration n minus 2. Okay, now using that form again, if we keep doing this recursively, we are going to be left with something like this. Okay, now I'm going to write this and then I will explain it. Okay. The last term at the end, because now it is n minus 2, it will be x tetration n minus 2 times x tetration n minus 3, which is from here, plus x tetration n minus 2 times ln x into d by dx of x tetration n minus 3, and this is going to keep continuing. So what do we notice? In every term of this sequence, the power of ln x increases by 1, the power of x in the denominator stays the same, and this product here, we keep having one extra power of a tetration of x. So each term gets multiplied by a consecutive tetration of x in this series. Okay, and this continues on and on and on. So this becomes ln square by 1 by x over here, which we will soon see once we multiply everything out. Oops, I forgot a by x over here. Okay, so this will become ln square upon x times x tetration n minus 1, x tetration n minus 2, x tetration n minus 3, and so on, so on, so forth. So I'm going to write the final result like this. Okay, can you see? Okay, I hope so. Okay. Plus ln x by x times x tetration n minus 1, x tetration n minus 2 plus ln square by x times x. Now look at this, is the last term, yes? Ln square by x times x tetration n minus 1, n minus 2, n minus 3, so on so forth. Yes, so x tetration n times x tetration n minus 1 times x tetration n minus 2 times x tetration n minus 3. And then the next term will simply be ln cube x by x, x tetration n minus 1, x tetration n minus 2, x tetration n minus 3, and x tetration n minus 4, and it will go on and on and on and on. So the general form for d by dx of x tetration n will be equal to summation from I is equal to 1 to n. It will be ln to the power I minus 1 x times the product of these tetrations. No, sorry, oh my gosh, I have made a huge mistake. This isn't a plus, this is a dot. This is a multiplication, not a plus. This is a multiplication. Sorry, this is a multiplication. Okay, so this is going to be multiplied by this multiplication, which can be expressed as multiplication from j is equal to 0 to I n minus j, no, x tetration n minus j. So that is the general form for this result. Now let's test it. Okay, so if I put n is equal to 1, let's put n is equal to 1. So basically d by dx of x is equal to, so let's just put n is equal to 1. So summation I is equal to 1 to 1. So this is basically ln 1 minus 1 times x upon x into multiplication of ln at j equal to 0. It is simply 1 in times that x tetration 1 times x tetration 1 minus 1. So which is equal to ln 1 minus 1 is simply nothing. So this is 1 upon x times x, and this is x tetration 0 is basically 1. So x times x cancels out. We get d by dx of x is 1. Let's try n is equal to 2, which means d by dx of x to the power x, which is equal to, let's put it into this formula, I is equal to 1 to 2 ln I minus 1 blah 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 blah. We get, so for n is equal to 2 we get, oh, I missed a sign again. Okay, we get x tetration 2 times x tetration 1 upon x plus ln x upon x times x tetration 2 times x tetration 1 times x tetration 0, and we stop here because we have reached the limit. Okay, which is equal to this cancels out. X tetration 2 is x to the power x plus ln x tetration 1 is x, this cancels out. X tetration 0 is 1, and then we have ln x into x to the power x, and so we get, and you can also verify this by other means, and we see that for n is equal to 2 this result is still valid. And yes, also for 1. Now finally I'm going to try this for x is equal to for n is equal to 3, which is d by dx of x to the power x to the power x, which is what was in the original video. Now looking at the terms, we have x tetration 3 times x tetration 2 upon x plus x tetration 3 times x tetration 2 times x tetration 1 upon x times ln x plus ln square x upon x times x tetration 3 times x tetration 2 times x tetration 1 times x tetration 0. So this is equal to x tetration 3 x tetration 2 upon x plus x tetration 3 tetration 2, and x tetration 1 is simply x, so this and this cancels out, times ln of x plus x tetration 0 is 1, so this cancels out with this, plus ln square x tetration 3 x tetration 2. Now taking all of this common, we get x tetration 3 x iteration 2 times 1 by x plus ln x plus ln square x, which is also the very same answer that we got in the video by blackpenredpen. Now I assume that this will continue. I have obviously not checked this for very high values, but this is one method that I found to find a generalized formula for the expression nth tetration of x, and using that generalized formula we have just proven that it works for n equal to 1, 2 and 3. So the final answer that I have is that d by dx of x tetration n is equal to the summation of I from 1 to n of is ln to the I minus 1th power of x upon x times the product of j equal to 0 to I of x tetration n minus j. This is our final answer. Thank you everyone, and I hope you enjoyed this video.